We were seduced by convenience and power. As an energy source, oil has no equal. Like wood and coal, it burns in air. But as a liquid, it's easy to transport. And the power of ancient sunlight stored in the strong bonds between carbon and hydrogen atoms can release 100 times more energy than it costs to get it out of the ground.
The thing about oil is it has incredible energy density. You know, the old question which the schoolmaster puts to the class, what will fill a teacup and lift a ton 1,000 meters into the air? And the class looks vacant. And of course it's petroleum. You can put that much in a car and you can drive up 1,000-meter hill and you get there. It's an astonishing amount of energy in a small volume.
Put Royal Triton in Cynthia's little tummy.
Right, lady.
Cynthia will just love that Royal Triton.
Energy-rich hydrocarbons made engines and transport the obvious use for oil, but it was far from the only one.
There was one T-shirt that says, what else does oil used for? The ink on this T-shirt. The T-shirt. There are hundreds of different hydrocarbon molecules of different shapes and sizes in a single sample of oil. So the first task of a refinery is to sort them out. So the first big thing was to modify it for automotive gasoline and even more demanding aviation gasoline. Then diesel fuel came along, then jet fuel. Then the refiners started to develop ways of taking the bigger molecules and cracking them in half, or taking the smaller molecules and gluing them together.
And in this way, the modern petrochemical industry was born. About 10% of all oil is now converted into pretty much everything from plastic to paints, pesticides to painkillers.
We're born into these, the sterile rooms. The plastic gloves catch us as we come out. We're swaddled in polyester. And then we live our lives bathed in oil.
Even if you don't think a product has oil in it, it probably does. From the nets of fishing boats to the fertilizers on farms, petrochemicals have become indispensable components of human society. And oil, the fuel of choice to move everything around. The Ghawar field would prove to be the largest oil field ever found on Earth. A supergiant, it was 22 miles wide and 108 miles long.
In terms of global resources, it's one of a kind. I would say the North Sea, for example, would be 1/10 of Ghawar by itself, the entire North Sea.
The discovery would change our world forever, in more ways than we could ever have imagined. The discovery of the world's largest oil field in Saudi Arabia in the early 1940s kick-started a dangerous rise in the demand for oil all over the planet. The world has been awash with oil ever since these massive deposits were uncovered in the Middle East. Everyone wanted a piece of the action. The Soviet Union moved into the Caspian Sea deposits near Baku in a big way, pumping dry one well after another.
I've been
sitting here since 8 o'clock this morning. How about I didn't go to work yesterday because I have no gas?
There's no need for panic or panic buying with the long lines we've seen on TV.
There was a little pandemonium at the pump during the oil crises of the 1970s, but it didn't stop the planet's thirst for oil from growing steadily at about 2% per year.
Stop the line, you're going to have to go around the corner. The line starts at the next street.
And shut out of the Middle East by OPEC, the big Western oil companies simply turned up the heat elsewhere. Rigs began pumping oil from technically challenging areas such as the North Sea, the Gulf of Mexico, and beneath the Alaskan permafrost. There were a few concerns about air pollution and oil spills, but the world hadn't started to worry about global warming or the end of oil. Imagine a gigantic building a mile across on each side and almost 3 miles high. This is the volume of oil we burned in a single year in 2004. Over 2.5 cubic miles of it. Each year we guzzle another building like this, and each one climbs another 10 stories. Every day, over 84 million barrels of oil are transported and burned.
We go from 84 million barrels a day now to 110, 120 in 15 or 20 years' time. That's what everybody's assuming. All governments and all companies, all markets, but a growing body of us ex-geologists and current geologists who work in and around the oil industry who study this problem think it can't be done. That in actual fact, the peak of production is really close. I believe it's 2008, plus or minus 2 years.
It could have been as early as mid-November and as late as January 6, 2006. But my line is, it's past. It's gone. My career as a prophet is over. I'm now a historian looking back at the peak.
We're dependent all of a sudden on rapidly shrinking supplies of ever more generally expensive oil. And that is the shock that's going to come to economies and the shock that will force us to go to the alternatives as quickly as we can.
The most optimistic market and industry voices see the peak far off in the future, if at all. They point to growth coming from new technologies, unconventional deposits such as the tar sands in Canada, and new discoveries. But as we settle into the 21st century, there are few corners of the world left to look in. The oil genie has granted us our wishes. Immense power, untold wealth, and a hoard of treasures. But now it seems we must pay the price. Hidden in the black magic of an oil reservoir is a climate demon from the distant past, and we unleash it at our peril.
We would go back to a world that is weirdly going to be quite similar to the world in which the oil formed in terms of temperature, state of the oceans, and so forth. So there is a certain irony in this whole story.
It was here, in the 100-million-year interval between the early Jurassic and the mid-Cretaceous, that the vast majority of the world's oil was formed. But what was so special about this time? We know the key to creating an oil deposit is for tons of organic, rich plankton to fall onto a stagnant seafloor.